That's what it is. Try that.
Panel, and we look at the right-hand side of the structure panel. So I'm going to take a guess here, according to our example, a character body 3D would be a giant example, a nose 3D would be a mammal, and the nose would be an animal. So this is all the same thing, it's just extending the straight of these figures. This is used to make objects transform instead of coding everything from like the base node up. Then you have to look at plus and here, you can kind of see this chain of command. I guess I wanted to put some of even it's like, you know, there's like a those what I look at is like everything with that maybe. So I want to talk to something that other dudes like the 15 game of like, you don't have to go from just no 3D, you can have to go into space, you go from go 3D, physics on go 3D, and you get everybody 3D. In this case, we're trying to build a player, but if we just get all the way to there, and then we'll get in that process of creating that thing. This is actually the biggest thing that we need to do. We've got to see that if you get the things to get yourself, it's kind of cool. I don't know if you can think about it, right? There are invisible players that extend hundreds of lines above this, to get to this part, so we don't have to rewrite that everything to get to this part. So let's go ahead and make the read, all the way down to the line 4. Basically, this is the first time we've seen it in a abbreviation. We've done it around 6 months, and there are many others in the coding node books. The program is big thing is very like specific names for my deep changes or deep shorthand for things because we don't want to type constant every time we do more efficient. So some specific constant, but really you shouldn't be running constant script. You want to read them variables first, but we're going to change this to being variable. All you need to do is either instance, use the X, which is underneath, so it's a variable, and then we're going to change these to variable. So why would we want to do that? So this is a sort of implicit rule called a convention. This is really just a basic convention. The goal is that it makes the code and service objects feel similar, feel the same. There's like lots of times there's really good at meetings that might be associated things, and there's a bunch of different sources. CD script, large case, and uses the lowercase. with underscores for variables, function names, and other stuff we're going to go into. And we call it extensions. There's different kind of cases we want to use, which is this sort of capital style, that's case, case. And I'll put a graphic up on the screen here of all the different types, which is what we're interested, that's the section we can do. I'm trying to find that something like using a function that typically is capitalized is really convenient because you could be underlined and code down the thing and do something like this. You're talking about uptime speed outputs, knowing that, oh, that is a constant. Literally, you can know right there, read it instead of going to average and something second. Yeah. So the speed is this is how you declare the variable or tell the computer that we're going to make a variable. Variables are people calling themselves, so we're going to make sure that we cover this pretty well. Like making a game involves peanut butter and jelly, this is the variable. And then we'll get to the jelly. So when we say what a variable is, think about it like a box. It's a box that controls about the next factor of box here is the name that we want to throw for some of the box. So we can have a room full of boxes, we can plan the box list for something we can throw them in. So I want to do display the speed. Equal sign. And you don't always have variables when you declare a variable. The equal sign, in this case, we call it the initial. What that means is we're going to take the value on the right-hand side, and we're going to put it into the box we define the code on the left. When a variable is declared in a file like this, and there's no indentation in front of it, we have to call it the same word makes symbol. That means something different depending on the location. So again, it's different definition. There is some it is because these are the code and understanding what they're trying to do. It's code, so you have to get on this to be really useful because we have a systems from the side, because we maybe other people don't see that when it's technical, or they don't know what's on the side. Because we're speed on the first basis or something. To do this, we can add something to a variable declaration, which is called annotation. We have a special annotation. Make an annotation, you have to start with symbol, then you can type a quote, and you notice that on the right hand side of the box, the further thing, so the first book, and we see speed, with the reduction. This is showing officially player. This is the side of your own versus custom structures. Yeah, this is in a box, and you sort of have like 10. Even though our code is built up in the same. And you can see that we put the meaning you can actually hit them and do something like this. Let's go ahead and uncomment and we've done the drawing, so go back to the constant, and now we go variable inside that number. We're back to the constant, and now we go variables are constants that would be really unique. Constants are just a variable that never changes. The box has at the beginning, and that box will always have that beginning. Alright, so let's go ahead and uncomment line 7. Read that error message first. We have an error expected indented for non-average function declaration. Hey, look at that. We have our word declaration. This is a function declaration, and that's why we have the function. And this is the other, most important thing is our identity. This is the jelly to our peanut butter. Almost all our identity is have variables and functions. There are some that don't, like frame, you say frame? This is the jelly to our peanut butter. Almost all our identity have variables and functions. There are some that don't, like frame, you say frame? If anybody is wondering, this is where the term edge word comes from. Yeah, so if you know that program is frame, hey, what if you just didn't do that? The functions are when you start writing the code that actually does something. Because variables with no data, they don't even do anything with that data. That's why we have to use functions. And this case, we're declaring the recover function, underscore physics process, and then we have all this other crazy looking simple stuff happening after that. Yeah. I think it should be better to start with a much simpler function, and come back to this one. So go ahead and find out this one. The other one, you're going to see a count. It's going to be underscore, right? Counting 1, 7. We're going to go ahead and type func, and the func people are declaring the random function. We're going to give that function a name. It's going to be underscore ready. And we're actually going to ignore the function here because I think it's good to so it's the technique for yourself a few times, feels good to rough. So ready? And then we're going to do parentheses and then quote. Alright, so we're going to hit the enter key and then hit tab and make an indentation. And it's there.
Brackets and variable separation and with the colon instead of a semicolon. Such a difference. I'm too used to the fucking anal syntax of C++. That's me. Perfect. It's like taking the. It's not even like taking the training wheels off. I think putting training wheels on. I don't know.
Basically, capture spaces at the end and it's actually really important for the computer that's learning how to do those things together. So you can see this a lot of statement blocks in particular, like we have a bunch of instructions, each on the functions hold in a list of statements. So that's second word just lines together. GDScript is something called in white space significant language and actually are automatic again. Perfect. Maybe few times feels good. Code completion here.
This is good because at the very least teaches me a bit more about like GDScript specific things. Maybe they're right. Maybe it's like really easy to learn these languages if you already know how like to use a lower level language. Yeah.
The name is going to be underscore ready. And we're actually going to ignore the code completion here because I think it's good for you guys to type this for yourself a few times. Feels good to rough, right? And just type it ourselves like men. So then you're going to do parentheses and then colon. All right. So we're going to hit the enter key and then hit tab to make an indentation. And actually, our automatic identifier. Perfect. GDScript is something called a white space significant language. We use tabs or spaces at the beginning of each line. It's actually really important for the computer to determine how to group those lines together. You're going to see this a lot with statement blocks in particular. That's when we have a bunch of instructions, each on the functions hold in a list of statements. So that's that second word which does something. We're declaring the function up here. Now we're about to write the statements of what it does. And the first statement we're going to learn about, which is necessary for GDScript, is pass. Pass is, well, it's just a placeholder that says functions don't actually do anything just because they exist. Something has to trigger them, which we call calling a function, so something has to call the function, and then we go run the statements with instructions for inside it. Ready is a special function that Gt7 is going to call for you on the node. This function is called the moment the node this is attached to enters the scene and is ready to go. It doesn't necessarily only mean when the game starts. It's when it appears in the game. Let's start right. There's some details here. So we're going to delete pass. We're going to go ahead and write print, and then we're going to put the parentheses. And why don't we just put speed in between the parentheses? So we're going to basically do a lookup, find a box named speed, and then pass the value of that box along to print. Let's go ahead and try it again and see what this is. Doesn't look like anything happened, but something did happen. We got a notice output's highlighted. Yeah, right? So we're on this output tab. This is our console. Print is a function defined somewhere in the bowels of Godot. And its whole job is to print what is console, and is a way for us to basically talk back to ourselves from it. So that 5.0, what value is it? 5. But it's speed. Let's try making a new function above our ready function. So that's going to start by doing the function word. So we're declaring that we have a function. And we got to get the function a name. So let's just do get boosted speed. 2 underscores in between. Let's practice that speed choice we talked about earlier. And then we're going to do the parentheses. So if we were going to take in values that we could use as arguments for a function, or parameters, or whatever, that's where we would do it. So we're not going to do that right now. So go ahead and do a colon. And then we're going to go to the next line. And we're going to start adding statements for our function. And we're going to introduce a new statement. And it's really important. So this one's going to be return. So right now it's fine, it's happy enough, but we're not doing anything still. So, much like that return, kind of, it is doing something. That's going to be important later. But in this case, return is kind of like a special magic word that says when you hit this, exit the function. And right now, we're exiting the function with something. So if there was code below this, it would work. If there was code not below it, but below inside.
Like most people probably feel like the guy who's like basically teaching here is like the door, like programming experience necessarily final. But I feel like the guy who's teaching him, like has to kind of baby the audience a bit. Like, this is a return statement. This exits the function. It's like. But it's good. It means I'll probably. I'm going to probably be
add this function where it's happening. Yes, and that's a good point. So go ahead and do like print speed directly under this return. So when this return is hit, this print speed will not work. Let's return something. So we're going to return speed, and then let's change speed a little bit. So this is boosted speed. Let's just times it by 2. And you're going to use the ampersand to multiply. So on line 12, replace speed. And we're going to replace speed with get boosted speed. And we do want the parentheses exactly as we have, because get boosted speed is a function. We want to call that function. And now, when we play our game, let's see what comes back.
That's pretty fast.
20. We see 20 because we have, I forgot we have 10 in the probably 10. Yeah, right. Everywhere. That's an example of how we made get boosted speed, and when we call them, it's an expression because it's producing a value. And this also demonstrates why we have functions in the first place, which functions let us build reusable pieces of code. Like imagine that maybe there's a more complicated calculation needed to do for get boosted speed. We kind of group that together.
There's speed there.
If we needed to. I don't know if the return thing still.
What's different there?
It's like replace if we needed to. I don't know if the
return thing still. And then there's the gig teaches how return works. Jump to 2 minutes and 2.5 minutes to skip this segment.
It's like when you basically make this function out without this, but I do print speed times 2.
No.
So the print function says I return to
You should do that smooth as if it's the throttle on there.
But it gave us back nothing.
What was the peak? 65% throttle? Right here.
If this is a low, it gives 10. I'm telling you, Nick. It's not. It gives.
Damn, that is consistent as hell.
It does talk to the console. It gives nothing and it writes to the console. Yeah. 20 minutes later. I think what you're saying is it's like where it's a weird. So it's like the whole thing. It doesn't have a value. Like, because I think almost like this, the fact that it's a number is almost a bad example. I'm thinking it's a value.
Back on the throttle.
Really, it's a separate thing. It's going to the console. It didn't give us a number to multiply by. Could I do this instead? Speed times 2 inside of there? Exactly. I'm a freaking genius. We're learning, baby. Oh my gosh. That is, I felt so many levels of Einstein. Like I was going into like relativity. Yeah, that felt really good to figure that out. That felt really good. Good.
Yes. That's the aha moments. Like the more you figure those out, like that's really what gets you. We figured this stuff and helps you think through it.
Sorry to put a little end cap on that. I was like, why are we using return here?
Modulating
We could have
it.
done this, but return is used to like break the function.
Return is used not just to break the function, but to also return something out of the function. 20 is being made right there.
Yeah.
But we're not doing anything with the 20.
Return is a way of saying. See, I think I'm missing what box it's going into.
That's a great way to put it. So when you said get boosted speed and call that function, it's kind of a magic temporary bump. And then when we return, it's kind of like putting
Flip off the throttle.
that imaginary bump. And then once the function is all done,
Zero, quickly back up to 100. That's down to zero. Back up to
The tricky part here is that the main function for like running the game, like the 3D simulation, all that stuff, is just not like there. When you like create a script for like the player character and stuff like that, you can define like the functions of that player, but like you're not getting to like work with the script of like the game engine starting up, running and viewing the 3D elements like itself. Like that is all abstracted. It's out of the way. It just kind of handles that for you. If you're able to see it, that like it's calling it from that function. I guess that would be clear.
lost the function from
So yeah, I can see it being more difficult to like load programming this way if you don't understand like what's happening underneath it all.
rift analyzer?
with what we put in
Oh.
imaginary box.
But we gave this
Hell yes.
that happens to have that 20. But if we didn't have return, reversing, the 20 would never be put into the box. Right. It's like the movie Tenet. Basically, I can catch bullets backwards now.
Yeah. So return lets us split the function at that point, and optionally we can provide something back. So we can produce a value that whatever's calling the function can.
There we go. Let's put some real
We've
data.
talked about arguments, we've seen them used with print, but we should probably actually show how to make those for ourselves, because we're going to do that. We're going to go up to the parentheses on line 7, and we're going to define
All of that stuff for 2 semesters wasn't for nothing. I actually feel smart now.
what arguments or parameters we're going to take in. Now, they're actually just variables. They're just called something different because they're in a different spot. And unlike the variable declaration, we don't
Great
have to use
card.
the keyword. It's just kind of implied by where this is.
Yeah, I didn't know.
We're going to take in boost multiply.
We're making up this word about it. You can make it something similar.
Yep. And where we have 2 on line 8, we're going to replace that with boost multiply. So we're taking the value in the box of speed, we're timesing it by the value that will be in our box boost. In about 2.
We're making up this word about it. You can make it something similar.
Yep. And boost mode, just kind of in determining parameters we're going to take it. Now, they're actually just variables. They're just called something different because they're in a different spot. And unlike a variable declaration, we don't have to use the bar keyword. It's just kind of implied by the word this is.
Yeah, I didn't know.
Okay.
We're going to take in boost multiply.
We're making up this word about it. You can make it something similar.
Yep. And where we have 2 on line 8, we're going to replace
How
that with
did blue have more coming out? 16 going in. Okay. Now let's get to this corner. Okay, next one. Let's see. High entrance.
boost multiply. So we're
take that corner really good, actually.
It's the sixth one. Or maybe something in a different spot.
See,
And
my
unlike
exit was so
decorations,
good.
we
Like,
don't have to use the bone fuses. It's just kind of implied.
okay, well, let's add a little bit of something.
It has some fucking parameter into a function that hasn't been declared. It's actually just the its declaration because we have to use the fucking.
Okay, so we'll go 100%. That stop's already on. Right. Here, already letting off.
We're going to
Yellow
take
is
it.
still on.
We're making up this word now. You can make it something.
Now yellow is off.
And where we have 2 on line 8, we're going to
Brake pressure starting to get applied.
So we're taking
Brake pressure, a little bit of throttle there.
Plus having to like explicitly define
No brakes yet.
as an integer or like a double.
Now we're braking.
It's just like, nope. It is that thing.
Braking.
Whatever you typed, it's
Coasting
whatever
there.
you want it to be, and it's like, no, I want it explicitly
Little more
define what it is.
Not much.
Actually, I could probably do that. So,
Hell of a lot more speed. Oh, Jesus. A little bit of.
Speed that out of this function to the field right
Breaking our
in.
leg car.
And you'll notice, go ahead and read the error that's kind of
It's already pulling.
For
Who's going with the gas first?
Because there's nothing in here, maybe. I've expected at least one, but received a 0. There you go. I think I know what's about to happen. If I put a number here, the multiplier, because we multiply speed right here in our return function, our return statement. We could do a 1, and it would keep the same, 2, and it would multiply by 2, 3, triple it, etc. All right? You are right. Yes. Good. Knocked it out of the park. Let's introduce our audience. Strings of
oh, that calls it God.
Okay. That looks pretty good.
Yes.
so quick, and we're going to do that.
Try to rate down a little more fuel consumption out of that.
Yeah, that's
Right above line 12, we're going to do another print. We're going to do quotes, and then we'll just put a message like about the print versus print. Can we just cover the data type so fast? Like, there's a lot more. There's the primitive method. Yeah, why don't you do it? On the fly, let me see if I can do it. All right, an integer, which is a whole number, no decimal point. Float, which is a number with a decimal point. A bool or a boolean, with true or false statement.
That's a lot better.
Is going to be text like words. String is any text that's surrounded by quotes. We have to put in these quotes so the computer knows it's like a string of characters. Like we're actually saying these words. Yeah, that's the plural. You got it. Oh, did I get them all? If you were in theaters, you could better do it. Okay, I got it. All right, we'll go ahead and play that real quick. And we'll see what happens. That becomes speed. Line comment, line 14. For the rest of this function, I think what we should do is we should do a lot more of a cause and effect thing, because I want to get out of just like sitting in theory land the whole time. We're going to scroll all the way to the bottom, and we're going to uncomment move and slide. So if you hover over move, let's go ahead and do definition of this. Moves a body based on velocity. If the body collides with the node, it will slide along the other body rather than stop immediately. If the other body is a carrier body 3D or rigid body 3D, it will also be affected by the motion of the other body. You can use this to make moving and rotating platforms or to make nodes push other nodes. But I think it's important to also call it that moving slide is a function made in the game engine of Godot. Like, moving slide might not be a part of Unity. Godot has made these
functions that they see frequently used in game design, in their game engine. So they're like, we're going to make this function for move and slide. We didn't make it. It's somewhere else in the Godot engine that's grounded in their engine.
Let's talk about what the heck physics process is. Yeah. Just like ready, physics process is another function Godot gives us, and physics process is going to be called automatically by Godot during each physics step, or each physics step. You probably heard the term rate or FPS or whatever. I mean, the gamers here, right? That's how fast. Physics process also makes more sense if we talk about. You probably heard the automatically by Godot during each physics step, or each physics step. You probably heard the term rate or FPS or whatever. I mean, the gamers here, right? That's how fast it is. Physics process also makes more sense if we talk a little bit about process. Process is a function that would be called every single frame that the game is running. There is a function that looks like that. Yeah, why don't you go ahead and just print something out of this function? Alright, okay,
I think it's going to hit every tick, which is every frame, which is going to be like 60 a second, or 110, whatever, I don't know. Yeah, 40 seconds, yeah. There's so many, you can see it racking up with the exclamation point right there.
It is running a little bit, every 6 zeros, right? It's called automatically, this is another function Godot gives us, and physics process is going to be called automatically by Godot during each physics step, or each physics step. You probably heard the term rate or FPS or whatever. I mean, the gamers here, right? That's how fast it is. Physics process also makes more sense if we talk a little bit about process. Process is a function that would be called every single frame that the game is running.
There is a function that looks like that.
Yeah, why don't you go ahead and just print something out of this function? Alright, okay,
I think it's going to hit every tick, which is every frame, which is going to be like 60 a second, or 120, whatever, I don't know. Yeah, 40 seconds, yeah. There's so many, you can see it racking up with the exclamation point right there.
It is running a crazy frame rate. It's probably 144 times a second. Yeah. And delta, the thing that is just past the process, that is the amount of time in seconds since the last frame. We use that for frame rate independent movements,
and all this does is like, it makes it so the game doesn't run according to how good the machine can handle running. There's rare instances, it's usually like in an indie game, where somebody didn't multiply something by delta, so the game really moves faster. Like, it would run faster if your game is running it faster. As in, like, it's getting 120 frames, but you'd be slower if you're running at 60. It's the weirdest thing ever.
The reason we have physics process and process is that physics needs to be processed in a very stable way because physics calculations have so much stuff going on. Think about like in most of your games before the day. Most of the time, are you getting 144 frames? Sure, maybe. But sometimes you're going to dip down in frames because process is physics going on. Process in a very stable way because physics calculations have so much stuff going on. Think about like in most of your games before the day. Most of the time, are you getting 144 frames? Sure, maybe. But sometimes you're going to dip down in frames. This process is how fast the game is running in longer. If your physics calculations are designed to run at 120 frames a second, but suddenly it's set up to 5 frames, but those calculations are going to start to get off, even with delta. So there's some clever stuff going on with the hood that Godot is doing when it executes physics process. Another thing that often happens, and we are going to see this in the series, you might run your physics slower than your game is rendering. In Zelda, after it's stuff ran at like 20 frames a second. Yeah, or something, 24, yeah. So even if you render it at 60 frames a second, your world calculations, your physics, collision detection, your movement, all that kind of stuff is actually happening 24 times a second. Even if you run at 60 frames, 120 frames, 180 frames a second. And we will be replicating. My question is, are we going to use, because, yeah, we're letting the players, but it's kind of like a mainstay of, like, giving me a game. So we're going to eventually need a function and a process, or are we just going to use function physics process and players? There will be cases where we'll use function process, but for the most part, you should be doing a lot of your game logic in physics process, especially if your game is tied to the physics system like that. So get that out of your physics process. Yeah, let's move on to the first logic game logic in physics process. We just say of like, it's going to be in our game. So we're going to eventually need a function and a process, or we with 60 frames, 120 frames, 180 frames per second. But we will be replicating that.
My question is, are we going to use, because, yeah, we're letting the players, but it's kind of like a mainstay of, like, gaming a game. So we're going to eventually need a function on the process, or are we just going to use function-based process on the player?
There will be cases where we'll use function process, but for the most part, you should be doing a lot of game logic in physics process, especially if your game is tied to the physics system like that.
But get that out of this physics process.
Yeah, let's move on to the fourth to the physics system like that.
Last.
Yeah, let's move on to the first couple lines and then physics process function and then uncommon code and then human. So we have an new keyword we haven't seen before. We also have two new keywords we haven't seen before. The first keyword is this is a control flow statement. I thought it's kind of a pink color. And if statements allow us to basically say, hey, we're only going to do this kind of code below if our condition is true. And the condition is going to be the thing to the right of the word if and before the colon at the end of the line. Not takes whatever value is on the right-hand side of it and flips it. If the value on the right-hand side is true, then it would be not true, meaning the result would be false. So why don't we go ahead and read through the condition part of the if statement, that's the not event flow part, and why don't we figure out kind of those two.
Well, it's kind of funny. We have a thing called is on store, and that's a medium group, that's a function that is also in the Godot engine that's pre-written for us. And it's kind of like, I love these ones that are like, it is just a thing. So it's like, if it's not on the floor, do velocity is equal to or greater than that? No. Velocity, add it to get gravity, which would be gravity, times delta to make everything different. Which is also weird to me because I'm like, why would we do it here if we already have it up here? Maybe not.
So how we would read this is, if we're not on the ground, we're going to need to apply that. I mean, you know, velocity,
Well, not really. It's a very faintly math-like thing, which is also pre. Written. But it's a property. It's like it's something in the environment. Velocity means velocity typically used for the standard and not the imperial system. Used and modified. During to movement side. So it's relating to movement side, which movement side is all about the movement of the body based on velocity. Look at that. Okay.
Let's talk about assignment first, and then we'll talk about plus sign, kind of throwing a wrench in there.
And then when the time I got again, I started this function we have done.
Well, at the start of the function, we're supposed to read it. This is we're actually using it.
Why don't we have and the first time I got again, I started this function we have done.
So on velocity, look at that. Let's talk about assignment first, and then we'll talk about plus sign, kind of throwing a wrench in there.
And then when the first time I got again, I started this function we have done.
Well, at the start of the function, we're supposed to read it. This is where we're actually using it.
I don't have taken velocity. Oh, how do you write this thing that's like on the cuff?
Velocity is a property that's the font that's holding some data that's going to be used by users. Go ahead and do the plus sign on this line. We'll add it back in there. So when you see a equal sign, what we're saying is take the resulting value of the expression on the right-hand side, and we're going to put it into the box on the left. So we're going to put that into velocity. So the plus sign and the equal sign together is a shorthand for saying velocity equals velocity plus get gravity times delta.
So can't I just think about it like this way? You're taking what velocity already is and adding gravity to it.
We only do them when we're falling. So if they're not already on the ground, then we try to add gravity to the ground. And then once we're on the ground, we don't need to worry about it. There's no reason to keep doing it.
I also noticed that we had an indent after an if statement.
Right. It's like a function takes a block of statements, and if condition takes a block of statements. These statements under this if are only going to run if this check is true. Otherwise, this kind of skips over. It just jumps to the next not-indented section. Why don't you go into your previous user, and let's just drag our full player character bugs through these node is selected, and then move them up, and let's hit play and see what happens. And, Good. Let's go back to our code. Figure what else that is selected, and then move them up, and let's hit play and see. Why don't you go into your 3D scene viewer, and let's just drag our full player character from 3D node is selected, and then move them up, and let's hit play and see what happens. Let's go back to our code. Figure what else.
If input is action is pressed, so this function is saying what key is pressed, and now it's using quotes to write a string that figure what else happened. So let's go back to our code. Figure what else happened. Handle jump. If input is action is So this function is saying what key is pressed, and now it's using quotes to write a string that references in our project setting input being one of these. That's what it's written as telephone. It tells you on there, but if the UI set with the spacebar is pressed and it's on the floor, it's going to jump. Velocity.1 rise up. While it goes up and down, positive one is up. So this setting jump velocity with a time change is 4.5, and the gravity will slow it back down. And then the jump velocity is currently, I was like, is currently capitalizationized because it's a constant with, are we okay with this reading right now? Yeah. If we want to make the jump velocity higher, we could change up here. So, imagine we're going to be on the floor this time. We're going to be able to hit the UI step button, which just go half the D space, and then fly up 4.5 metric. Explaining why it's a little bit further, we have, if we touch the space bar, that's what the first that is, and we're on the floor. And is another field, and what it does is if both sides of being are true, then I would be a true. If either one is false, then the whole thing becomes false. And then this chunky code went on. Let's go ahead and try removing and do the go ahead and do it. So you can jump, but then once you just smash the face up, it's really good. Oh, look at that, it's flying. Because there's nothing to prevent us from adding more vertical velocity or more jump force, because we never check the people out on the floor. This chunky code went up. The weight card, explaining what a little bit further. We have if we touch the first side, and go with the first side is, and we're on the floor. And is another field. And what it does is if both sides of being are true, then I would be a true. If either one is false, then the whole thing becomes false. And then this chunky code went up. Let's go ahead and try removing and we're going to go ahead and do it. So, but then once you just smash the face up, it's really good. Oh, look at that, it's flying. Because there's nothing to prevent us from adding more. Vertical velocity for jump force because we never check the people out on the floor. So why did we I literally was just going to say this. If I wanted to double jump, I would set something that's like, don't activate this if statement until one button, or sorry, more than one button. You'd have to track like how many times have you done, right? And then you would reset them once you hit the jump. I'll provide it. So why did I would be a student. If either one is false, then the whole thing becomes false. And then this chunk of code runs up. Let's go ahead and start removing and we're going to go ahead and do it. So jump, but instead, once you just smash the face, it's really good. Oh, look at that, it's flying. Because there's nothing to prevent us from adding more vertical velocity for jump force because we never check the people out on the floor. So why did I literally was just going to say this. If I wanted to double jump, I would set something that's like, don't activate this if statement until one button, or sorry, more than one button. You'd have to track like how many times have you done, right? And then you would reset them once you hit the button. I'll provide an example to exactly what you just said. So back to you on forward section. We go on our forward section now, if we're on the floor, and let's keep moving to the next
few lines of code, uncomment lines 23 through 26. So this is where things start to get kind of crazy. Not so much on live content. We are making a variable or box of input there. There is short for direction because, again, programmers, we don't want to type if we don't have to. And we haven't really talked about the whole input dot thing or velocity dot thing, because this is called accessing a member property or function or whatever on some kind of an object, some kind of an instance of a thing. If input is a lookup instructions going and getting a thing, and then the dot says, hey, on that thing you went and got, we're going to call this function. So look in that thing to find this function, and then we're going to call it just like we would call any of the other functions. The vector be the direction. I say multiple vectors, what the kind is. The commas here are the directions that build up the vector. Vectors are the thing we're going to see a lot in programming in games. They can represent a point space or a direction of something. Usually they'll be their own type of vector or capital V, and the number at the end tells you how many numbers are inside the vector, because a vector is just a sequence or a set of numbers. To access each part of that vector, you're going to have the property called x, property called y, root for vector 2, and then vector 3 will extend that by adding a v property. In rare cases, you might see vector 4, in which case we'll add a w property, but that's the general gist of vectors. There's a bunch of math functions and things on them, and they're used pretty heavily in programming, and we will be math functions and things. On them, and they're used pretty heavily in programming, and we will be talking about them a lot more as the series goes on, but that's all you really need to know for it. Input direction, we're getting a vector 2, so there's an x and y. Wait, x value would be, why is it a vector 6? Because it's a vector 4? Or 6? This is a vector 6, because it's kind of like representing the heuristic. When you hit A, it's going to be either positive x or negative x, depending on which, and when you hit G, it'll be negative. But when you hit S, it's positive y. If you hit W, it's going to be negative y. And then the next one, the direction, this is where we're taking our layered input and we're transposing it by our forward transfer. We are not going to get into this right now. We're going to cover transform in way more detail than that. Some comment, line 27 all the way to 29. So I'm noticing real quick that way earlier we didn't change the other speed. I'm going to change that, and I think in the first tutorial we covered this. To change multiple versions of these, I'm going to hit Control V and select Use Form, and this retype. So the speed, okay, let's see what happens. In multiple versions of these, I'm going to hit Control V and select Use Form. This retype change with the other speed. I'm going to change that, and I think in the first tutorial we covered this. To change multiple versions of these, I'm going to hit Control D and select these four, and this retype. So the speed, I'm going to put that. Okay, let's see what happens. Back to moving. Are you noticing that goes good? How did you stop giving me I let go, I was so good. I'm going to hit Control D and select these four, and that's retype. Okay, let's see what happens. Back to moving. Are you noticing anything? Goes good. What happens if you stop getting it?